board on this computer. Okay, there you go. It's recording.
Nice. So, um, my question, I'll paste it in here, is given the head of a singly linked list, write a function to reverse the list. The method will have the following signature. It is reverse list, and you're given the head. Oh, sorry, this should be over here. Pointer. Uh, but I have an example where if the list is 1, 2, 3, then you're going to return the head, which is 3, and it should point to 2, and then 2 should point to 1. And you're given this node struct. The data is accessed by this member variable val. The next node is node next, and it's just a default constructor. You won't have to worry about that. But the constraints for this is that they are positive integers, and there is always at least one node in the list.
Okay. All right. Is there like time complexity, like constraints on it?
Um,
Is there like a max?
just think it through. Big O of linear time should be
Oh,
what you aim for.
and no like space complexity, right? Okay.
Whatever you need to start.
Okay. All right. So first, I'm probably gonna start with like the the edge case, I guess. So it'll be like I'll start with, or so you said there's always gonna be at least one, right?
Yeah,
Okay, so I'll start with if like head dot next, or I should say like that,
yeah.
equals null pointer, right? I
Mhm.
guess is what I would start with. And then I would just like return head. So that
Yeah,
would just handle the
sounds
edge
good.
case right there.
Hmm.
And then let's see. I guess I'll think it out for a second or two.
Take your time.
I'm thinking of hmm, first. Okay, three, two. So I would start hmm, two, two, one. So it's a singly linked list. So I was thinking of like making a second pointer go to the end of the list, but I'm not sure how it would go back at that point then. Or maybe I could make a stack, I think, possibly. So what I'm thinking right now is like I make a stack, I'll call it S just for short. And then like I make a second linked list, I guess is what I was thinking. Or do I have to keep the same linked list? I guess it's the same linked list because it's the to reverse the linked list. So,
You should be aiming for constant space complexity,
mhm.
but
Oh, okay. So I'll
yeah.
get rid of this then. All right. So I was thinking, I don't know. My first thought was to use like two pointers, but I don't know how I'm gonna get back to the start or like, so for the first one, you can, I'm really not sure because if you make two pointers, then I just don't know how I'm gonna get back, if you know what I mean. So I'm not sure
Maybe.
that if that's the right approach, but mm,
Well, I could give you a hint on this problem. My hint would be to say, like, look at in the example, look at 2
mhm.
right here. 2, you want it to point at 1, right? So just think like the first time you just want it to point at 1. How do you get 2 to point at 1? Like what do you need?
So like two's next would be okay. Okay,
Yeah.
So two's next would equal the one before it, right? So you're
Mm-hmm.
basically just changing where they're pointing. Okay.
Yeah.
So then I'm assuming you would just iterate through the list at this point. Or not, I guess like so I would start at the head, I guess.
Yeah.
So node pointer start equals head, right? And I would start at the head.
Mm-hmm.
And then I would say while it's not equal to null pointer,
Yeah.
um actually I want oh yeah, that is constant, okay. And then now I have to reverse the way that it's pointing. So where should I start at head next? Because if I make the head point the opposite way, that would be wrong, I think, because that would just be pointing the null pointer. Kind of want to write it down, but
I mean, if it's at the or yeah, if it's at the end of the list, one should be pointing to null pointer. I
yeah.
might have not made that obvious in my example.
Okay, yeah, okay, that's true. So it'll be like now I just need to access previous one. So say I'm on. So right now I'll be on one. So I'm gonna go ahead and move to two because I can handle the case for one later. I can just set that to null pointer later. Um, so say I'm on two and I need one to point to two. Or no, I need two to point to its previous one, is what I need. Okay. So I'm thinking maybe I could use two pointers to have it point to its next, if you know what I mean. So then I can like
Yeah,
flip them.
sounds right.
So I would take this out here. I'm just gonna call them left and right. So then I would say no or left equals to I'll call it start or yeah, and then right equals start dot next is what I'm thinking. And then what would I do from there? So I have to change starts next or start and start dot next to point correctly. So start dot next. Okay. Hmm. Start dot next. So right. So right in this case will be like two, I think, and then left would be one.
So I'm just a quick question here. Are you trying to have the left and right pointers be like the adjacent nodes to start?
So so I should call this like current, I think. Not starts kind of
Yeah, it might be a little misleading.
misleading. So then like I'll have the left one be like the one that it's currently on, and then the right one be the one to the right of it, and I'm gonna try to like flip the two is what I was doing, if you know what I mean.
Mm. Yeah,
So
so left is going to be kind of like temporary, more so.
okay,
It's just holding the value of start, maybe.
yeah, yeah, that's true. So I'll call it temp. Yeah, that's a better idea. And then, okay. So I have temp equals current. So that would be like 1 right here. And then, so right would be 2. So I need 2's next. So I'll need right dot next equals, would it be current or would it be temp? Let me think about this for a second. I think it will be current. I'll have to check about that. And then maybe it's temp. Hold on. I think it might be temp actually, because then why would I temp? And then I was thinking current. Huh. Okay. Got myself stuck here. So I say current dot. So current would be 1, right? Okay. But I need that pointing the other way. No, do I need that pointing anywhere though? I'm not sure because okay. Here's what I'm thinking. I think I don't need to set currents next because that'll get handled or not. Maybe it won't. Maybe I need hmm, 1 dot x. Okay, I'm gonna do the case of 2 instead to get a better visualization because it's on both sides.
Yeah, generate. You can make all the test cases you need.
Hmm. So say I'm on 2 and its next is 3, right?
Yeah.
If I just have 3 pointing to 2, okay. Two's next is 3. But then when I go to 3, then what do I? Because I think I'm traversing it wrong at this point. I'm not sure. Because then I would be at 3. Because like in the current way that I'm doing it, I'm at 2, and then I need to make 2's next the previous, but I think I'm making 3 point to 2 right here, but that's correct. But then once I get to 3, I'm not sure how I would fix that. But okay, I'm gonna think it through. So I'm on 1. Hmm. I'm not sure if I'm just missing something small, but
Something that might help is that you really when you're doing uh like over every iteration, you're really only looking at two nodes.
mhm,
So what you really want, and you've been saying this a lot, you just haven't been putting it on the page quite yet.
yeah.
But what you do is that you when you have these two nodes, you just want the right node to point to the left node.
Hmm.
So,
Right, equal.
keeping that in mind, you want like a node and then the node behind it.
So you said you want the right node to point to the left node.
Yeah,
So
basically.
I'm thinking, okay, so I'll call temp equals current. And then wait, let's make sure that's not. So then right would be pointing to the left. So then right would be equal to current or temp. Let me make sure I do this right. Sometimes it's confusing. Right equals current, or would it be temp? I think right equals temp. And then is there anything I need to do after that was the thing I'm trying to figure out right now. Because then I just feel like this might mess up the the list itself. So I'll go through it like what I'm setting right now. So I start at 1, and
Mhm.
then I get, oh wait, temp. Temp equals current dot temp equals current. Okay. So I need to get this one. So I need to get 2. So I'm gonna say temp equals current dot next because that'll get 2. And
Mhm.
then I need temp to point to current. Wait, I need 2 to point to 1. So I need, hmm, okay. So then right also be current? So I have temp. Oh wait, no, temp is left. So I need right. Sorry. I thought temp was the next one. So right equals current dot next. That makes more sense to me. So now I have 2. And then right dot next equals current, if
Yeah.
I'm not
So
mistaken.
that's the like flipping, right?
Hmm.
That looks good.
I don't even think I needed. Do I need temp anywhere? I'm not sure if that would mess it up. So right.
Um, I'm not sure.
I'll try to just. I think I can delete it for now. I'll check at the very end. Or actually, I'll just like put a little comment it out just to make sure I don't need it.
Yeah.
And then I'll make sure that the edge case is handled at the end. So like, say we're at 3, threes dot next, because I don't want to access a null pointer at the end and get a seg fault. Current does not equal null pointer. So say I'm at 3, right?
Hmm.
So then I'm getting current dot next, right equals current dot next. So then I'll be getting null pointer and trying to access that. So I think I would need and current dot next does not equal null pointer. And then I would say, just to get to the end here, equals current dot next. And I think that traverses through the entire linked list, if I'm not mistaken. So I think I have the majority of it done, unless I'm missing something. I'll try to traverse through it. So I'll start at 1, and then so this starts at 1. So right is equal to current dot next. So right is equal to 2. And then right dot next is equal to current. So 2 now points to 1. Hmm. So, so should I be setting, okay, 2 now points to 1, and then I move on. The problem is, I think when I 2 now points to 1, I'm just trying to make sure it's not like a error with the logic here.
One thing that I do see is when you switch,
Hmm.
you are kind of losing
That's what.
the next node. Yeah.
Mhm. Okay. So you're saying I'm losing
Yeah,
2.
so when you say 2 points to 1, since 2 no longer points to 3, you can't get to 3. So something to keep into
Okay.
account.
So do I need to? Okay, that's true. Okay, so I need to keep that in mind. So I would probably need to access that or right equals current dot next. And then I'm saying right dot next equals current, and then I'm losing the original right dot next is the
Hmm.
problem. I could just set temp equals so temp equals right dot next is what I'm seeing.
Yeah.
And then I would need to temp equals right dot next. So two now points to one. Would I set temp? Okay, so how do I keep track of temp at this point? That's the main thing I need to do. So two now points to one. Should one be pointing to three, or should I guess one should be okay?
Well, you have temp right now. If you're at 2, temp would be 3.
Yes. And the last thing I'm trying to consider is that should I be making temp point to two, or should I make one point to temp? Is the thing that I'm trying to figure out right now.
Well, I think the reason that you have temp is for the traversal. It's nothing to
Mhm.
do with the flipping, right?
Mhm. Yes.
So if you want to go to the next node, like you want
Oh,
current to be temp. Yeah.
current equals current dot next. That's true, because then wait. Okay, yeah. So now that would flip these two, and then that would if I set current equal to temp, that would go to three, right?
Hmm.
Would But then would I be missing out? Because this would make this point like this way, right? Because then that would make it like that. But then
Yeah.
if I go to three, it would be looking at the next one, and it wouldn't be looking necessarily here, I don't think, is the thing that I have to try to figure out now. So right dot next equals current.
So I guess you want, yeah.
So I'm wondering if then I can set current equals current dot next, and then current equals current dot next, and then I just need to get a hold of three. So then I would do right dot next equals temp, if I'm not mistaken. Hold on. Right dot next. Oh wait, no. So now I have it pointing here, and I need current to point here, and then I think current equals current dot next, and then I would say current dot next equals temp, if I'm not mistaken. Because then two's dot next would be the one that was temporary. And then I can run it on the same thing. Um, I'm not sure. I feel like that's right in my head, but
Yeah, maybe just run through like a longer test case, do it step by step and see how it works out.
okay, okay. I'll definitely check that. I'll just do like 4, 5,
Yeah.
5. Okay. So we start at one. We we start at this. So we start head, right equals current dot next. So now we're at 2. Temp equals right dot next. So temp is 3. And then right dot next equals current. So that's probably the problem here. Because in that setting, right dot next is like, so then it's like setting it to 1, which might be messing it up, is what I'm thinking. Because if I do it like this, I think that's my main issue right now, is I'm not actually getting it set to temp. You see what I mean? Because like writes dot next. Right dot next equals current. Okay. Right dot next equals current. And then goodness. Current equals current dot next. I'll try to just run through it. Okay, so we start at 1. We set right equals current dot next, so right is 2. Temp is 3. Right dot next equals 1. So 2's next is 1. Current equals current dot next. Does 1 have a next at that point? Because 2's dot next is 1. 2's next is 1. Is 1's next still 2 at that point? So then current would be 2 at this point, I think. Because 1's next is 2, and then 2's next is 1. And then current dot next is equal to temp, which would be 3. So I feel like I'm not missing anything for that one, but then I could, and then I would start at 2. So current is equal to 2 if I'm not mistaken. And then right is equal to current dot next. I'm not mistaken. Hopefully I didn't. Current dot next equals temp. So right was equal to the last temp, which is 3. Temp equals right dot next, which is 4. Like right. Oh, wait. Yeah. And then right dot next equals current. So 4's next. Oh wait, no. Yeah. 3's next is equal to 2. But 2's next is, I'm just making sure 2's next is still equal to 3. So 2 equals 2 next. So current is now equal to 3. And then 3's next is equal to temp, which was 4. So, and I'm pretty sure that like, yeah, fixes it. And so now current is equal to 3. Right is current's next, which was temp, which is 4. And then temp is right next. Wait, yeah, temp. So now temp equals 5. And then so temp equals 5. Right's next is current. So 4's next is current, which would change it to this. And then so current is equal to 4. And then current's next is 5. So then right equals current dot next. So right is equal to 5. Temp is equal to right's next. So temp is null pointer. Current is equal to current dot next. Current is equal to, oh wait, no, right dot next equals current. So that changes it like this. And then current equals current dot next, which is 5. And then 5's next is equal to temp, which would set this to current next is equal to no pointer. And I think it will break the loop. So if I'm not mistaken, I think this is correct, but
Yeah, I mean, I think when you went through it, it looked good. So yeah, I think that that would be right. Can you just tell me the time and space complexity of this?
yeah, the time complexity would just be O of n because you're doing next until it's a null pointer, so it would just be going through every single node in the list. So that
Mm,
would be O of n. The space complexity, you're not you're making these three, but they're only taking up it's only like basically O of 3. So
yeah,
it should be a constant
yeah.
space complexity.
All right. Well, I think that concludes the technical part. Now I think we need to move on to the like feedback.
Feedback. Yeah.
Um, so what went well? I mean, I think you solved the problem, so that's good. Um, as for regarding technical solution, delivering a solution in a future interview. I think, I mean, you talked loudly, you thought through the problem, you went through the test case. I think that went good. And you asked me some good questions at the start, as to like where if it had like null pointer at the end.
Mhm.
So that was great. Improve their problem solving. Getting more practice doesn't hurt, I
Yeah.
suppose.
Yeah, for sure.
Uh, yeah, just linked list problems. I think I don't you. I think it might have been a problem with my question that I didn't specify the tail, but I noticed you might have had some confusion at the start about that, or
Oh,
maybe
okay.
I was mistaken.
Yeah.
Um,
I I think I wasn't assuming there was a tail,
oh,
but
well, yeah, I might have misheard you, but yeah, I
okay.
think overall went well, and I guess we'll move on to me then.
Okay, okay.
We'll use the same Google Doc, I guess.
Um,
Or do we have to, or
easy.
yeah, I guess we'll just
Should
move
like I
to
guess
the
like
next
you should
page.
I guess like maybe you should start like recording your one, you think? And like I could stop.
Uh, yeah, or I'll share my screen. I think we have to do the same recording.
Okay, same recording. Okay.
Yeah.
Hopefully my computer doesn't die. Hold up.
That would be bad.
Okay. I'm gonna stop sharing. Hold on. I will
Yeah.
because I wrote down my problem, so I probably need to like because I didn't have it like copied and pasted. So
Yes.
if you wanna share your screen, then I'll probably get started. Let's see. Put an example too there. Um this is it. Okay, well wait, let me go on the doc. So this was my one, and I'll show you like an example. So then roots equals like 1 comma 2 comma 3. So then I'm basically saying 1 is equal to the head, and then 1 dot left equals 2, and then 1 dot right equals 3. So this problem is you're given a binary tree. It doesn't have to be like a search tree. So it's not like I guess like sorted. And so you're given a tree and then you're given a target sum of some number. So I'll just for right now I'll say it's equal to 4. So basically it's like if the entire path is equal to, or if you sum up the entire path, does it equal to this number? So it's hard to like draw it on this Google Doc, but like say if it's 4 right now, since like 1 and 1's right is equal to 3, they sum to 4, it would return true. And if it's equal to
Okay.
3, 1, because 1's left is equal to 3, it would also return true. But if it's 5 and there's like no paths, then it should return false. Do you understand like that problem?
Um,
I could
so
put
wait, in this case, would it return true or false? It would return false, right?
this would return false because 1 plus either 2 or 3 would not would either be 3 or 4. So the only two cases where it should here is
Okay.
3 and 4. And there's like I could probably show you a I'm not sure how to put a visual on here. I can maybe try to like get a picture of one if you want.
Yeah, I mean that would be helpful, I think. I'm just trying to think through this. All right. So I'll just say like start off by saying Boolean, uh
Down at the
at
bottom.
some,
Yeah.
and I'm just given uh the root and this target sum, right?
And then that's the tree is defined like with value left and right, like a
Yeah.
usual. So I printed a picture. I didn't want to mess up your code, but I printed a picture down at
Oh, okay, yeah.
the third page. And so 22 should return true because 5 plus 4 is 9, plus 11 is 20, plus 2 is 22. And if it was like 27, it would return true. But like any ones where it doesn't add, it returns false. So do you see like what it's doing?
Yeah. This is
Okay.
kind of a difficult problem, I think. Yeah, yeah, think through it a bit.
Yeah. Oh yeah, for sure.
So I guess base case, just right off, if the root's null, then it's obviously false,
Hmm.
um, because there is no, yeah, it just there's no values.
Hmm.
So
That's correct.
um hmm. And I guess maybe another base case would be like if the root, if it doesn't have a left and if it doesn't have a right, uh, these should be equal, no PTR. Then uh, return if the root value is, can I just say val for the like
Yeah. Yeah.
data?
That works.
Yeah, if return if the root value is equal to the target sum.
Yeah.
All right. So I think whenever I like have binary search trees, I'm always thinking like recursion because it's just how a lot of problems are solved. So um, I'm gonna check out the value here. Oh. So what I'm kind of thinking is um the like there's like a different kind of like sum at every single point. So if the in this problem, if the sum is like 22, if I start at 5, then for each of these, like when I go to 4 and 8, the sum that I'm looking for is like 22 minus 5. So I think like I can kind of, that's like kind of a recursive call I could make, is doing like 5 and then like 4. 22 minus 4 is 18. So I'd be checking at 18. There is no right node for 4, so I just check 11. Um, like 11 minus, when I say 18 is, um, or 18 minus 11 is 7. So I would check if like, whenever the sum is equal to, um, yeah, I guess in my base case here, I check if the sum is equal to like or if the like target is equal to the value, then I'd return true.
Yeah.
So I think that would be right. Because I'm checking the leaf nodes, like whenever it has a leaf node where there's no children,
Mhm.
yeah, like then I return if there's a value. Okay, so I think I might start implementing that. Say, so for my last case, I will have like, I would call it remaining.
Mhm.
It would be the target sum minus my current like root, its value. All right, and then I think I'd return uh maybe checking this like recursive call for the left. Um, this would be a boolean. So here I'll say like, I'll say bool check left or something is equal to path sum. I'll say root left, and then the target would be whatever is remaining, and um would be the same for do the same for the right. And I guess I return like if either of them are true, because I only need one path. So I'd
Mhm.
return if that's true, or I'll capitalize this, or that's true. Okay. So I might use a smaller test case than what you gave me, because this is kind of a bigger tree for keeping track.
Mhm.
But I'll say like I'll say my target sum is like 5, and I'll have it be like 1, um, and then all these be like 2, and I guess this would be bigger, so it would be 5. Or I'll make that I'll make this 3, and then this would be, I'll have this be, oh, oh yeah, I just realized I messed up this binary search tree. All right,
It
I'll have
doesn't
my
have to be
uh,
a search tree. It's just a binary tree. So like the
or,
way you do it,
or a binary tree, but
yeah,
so it doesn't have to be in order
it doesn't
either.
have to
Yeah,
be a
you're
search
right.
tree.
Okay, thank you. So yeah, I'll have it be like this. I'll make that 3. I'll make that a 2. So that'd be 5. And then I'll make this a 1. And this a 2. Okay, yeah. So I think like that's a good uh
Mhm.
test case. So I start off, the root is defined, so I can just ignore this first statement here. And I'm starting at 3. It has 2 children. So um I just keep going, and I say my remaining sum. Um I got very lucky with making that base case. It actually turned out to be part of my solution. So
Yeah.
my remaining is 4, and I would check the left. Um, so I call it again. My root is 2. It has 2 children, or it has a child. So I keep going and I check uh its left with the remaining sum, which would be 2 in this case. And then I check the left. I return because 1 is a leaf node, and I say it's false because because 1 is not equal to 2 here, which is what I wanted for my remaining sum. So it's going to return false, which means that check left for 2 is going to be false. So then I check the right. Um, I could save some time doing it. All right. Whatever, I'll just keep going. Uh, the 2, then I check the right with the remaining 2, and it is 2. So I uh, return true, and that's what 2 ends up returning true. And then I go back up to 3, and I have to check the right again because like I haven't returned yet from 3. I'm on this line in 3. So I check the right and I say, oh yeah, it's um correct. Or I say it's not the remaining because the remaining here would be 4. So I return false, but then when I do return check left return true. So this would return true. So I think something I might change here actually. Uh, it wouldn't fix the big O time complexity, but it would like just save a bit of time in the small cases that I can just return the checking the left. Um, and then or checking the right. Yeah, remaining. And then I can get rid of all this. So I think it would just be that. All right, I think I'm done then.
Um, yeah, that's correct.
All right, great.
I think that might have not even been 25 minutes, so I'm not sure.
Oh, all right. Well, if it didn't take that long, then I think I might. I don't know if you have another question, but
I
I don't
have one
really.
more, yeah.
Yeah, then we can just do another question.
Okay, yeah. I'll definitely pull that one up. No, you solved that one like really quick, so
I've seen a problem like that before as well.
okay. Um, and then is this one. Try to make it. Oh, wait, I gotta put on the doc. I'll just do it under the. I guess I'll just put it up here. I'll put it like right under, I guess.
Yeah,
So there's this one right here. I'll also give a picture of that just to
yeah.
clear things up.
Oh man.
So here's the problem. So if you're given the head of a singly linked list, group all nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. So I think the picture does a better job of it.
Yeah,
Uh, so like it's really one based index. So it starts at 1 and then 2. So like all the colored ones in are like even indexes. And then so you have to do like all the odd ones first and then have that and then have the
Oh,
even
okay, so it is
indexes
one.
afterwards.
Yeah, okay.
Do you see what it means?
Yeah, I do, I do.
Okay.
Oh, I'm just gonna like, oh, whatever. Alright, I'll just go down here. It has all the gray stuff, whatever. So I'll just, so it wants me to return the head of the reordered list, I guess.
Yeah.
Okay, so, um, I'll just get group even and odd. I'll just call that. So I'm given the head and, um, so immediately when I start seeing this, when you're explaining the problem, um, I kind of saw that like what I could do is I could say like I could just have all the even and odd indices point to each other, and then have the end of the odd or the odd list point to the start of the even list. That might be a little weird to implement, but I'll try it out. So I'll say start off current is equal to head. It's always a good place to start. And I'll also keep track of maybe like a count. This or like maybe I'll call it an index, and that makes more sense. And then I'll like just start off iterating through the list. So wall current isn't equal to null PTR. Um, so I'll say since I want to have like a list that's all odd and a list that's all even, I think I'll need like a uh like an even head and an odd head. So I'll make it um I will just make them uninitialized for now. So like current odd. And I want it's odd before the even, right?
Hmm. Yeah, so the head
Okay.
is
So the head is odd.
Mhm.
Okay. So I'll say if the index is odd, uh so might be alright. I'll deal with the edge like the edge case later, but what I want to do is I want to say that okay, these braces are getting messed up. All right. So what I want to do is I have the like current odd next is equal to current. And I think that would be it
Wait, hold on.
for that. Um, and otherwise, if, or just say else because it's only even or odd. Otherwise, I would have the current even point, the next would be current. Oh, wait. So I think maybe I need to save the current at the start or something. Or like the next one. So I'll say like node temp is equal to current next. So I don't like lose any of my ordering. Um, this might get a little complicated. And I think I'll just have like current is equal to temp. And then maybe like right outside the while loop. I think that's where my while loop ends. I'll have uh like current Uh, or wait, I forgot. Also, I need to like increment, zero current odd next. So I need to increment, my current odd and current even after I insert a new node. Whoops, I do an equal sign. So, and I want the odd to point to the even. So I'll say current odd next is equal to, oh, but I need the start of the current even. Hmm.
I can give you a hint for that if you want.
Um, I think would it just be like would it just be the head? Or
I
no,
think
that'd be the odd. So it'd
yeah,
be the second index.
yeah.
Yeah, even head is equal to head next. Even head. I'm not quite sure if that is done, because it might be an edge case where they're not defined. So where like
Mm,
current odd and current even are not defined yet.
mm.
So maybe I can just initialize these, but oh, I also need to increment index.
Oh yeah.
So I can just say plus plus index. Um, and oh wait, what did I do here? Even is it, next is equal current. Okay. So if they're not defined yet, like if current odd is null PTR, I can just say that. Uh, if current odd is equal to null PTR, then I just want to define it as like I'll say current odd is equal to current, and then this will all be in an else. And then it would be similar for this. Let's see if current even is null PTR. Then I say current even is equal to current, and otherwise I do that. All right, so I think that might be it. I'll run through
Yeah.
the test case that you've given me. So when we start at 2, uh, the current is equal to 2, index is 1, and I have the even head should be equal to this 1 down here. Um, and I say current next is equal to 1. Um, and the index I'm currently at is 1. It is odd. Current odd is not defined yet, so the start is equal to 2. And then I just increment index and I set current equal to 1 because temp was holding 1. And then um, I'm at 1 right now, so I say the temp is equal to 3. My index is 2 now since I incremented it, and I run, and that is even. So what's down here? And current even is not defined yet, so I set current even equal to 1, increment, and set current equal to 3. And then I think, and then, yeah, temp 0 current next, so temp is pointing at 5. The index is 3, it is odd. Or, yeah, and that should set that, and then we enter this else statement, and I say that my current odd, which is right now is 2, that will point at 3, which is my current. And current odd is now set to 3. So looking at the test case, I think I got it right. Nathan, are you still there? Oh,
Oh yeah, I'm still there. Sorry, I have to plug my computer in real quick.
oh yeah, you're fine.
But yeah, it looks good to me. It's different than the answer like I had, but it still looks good, and I think it's like the same time complexity,
Yeah,
so it definitely looks good.
thank you.
And
I guess just move on to the other
yeah,
part then. I'll
uh,
stop sharing.
let me read what did it need me to say? So yeah, overall, like you did really good, I think, because you definitely talked like through your answer and like explained why you thought it was, and like you explained your thought process well. So overall, I think you did really good.
Yeah.
Um, as far as improving, I'm not really sure because I feel like you answered them both like really well. So, and I'm not sure. Do we want to
It's all
reflect
because
on?
of my great interviewer. That's why I was able to get these questions right.
Oh yeah, but yeah. Overall, I think yeah, you did a good job. So
All right. I guess stop recording and
yeah,